We're going to take a brief break from our administrative stored procedure, and I'm going to teach kind of the basics of functions, or just I should say just a basic function today that calculates rates. Because when we're running a stored procedure, especially that does administrative work, sometimes we may want to compare it, let's say some data to former data, and this is true with anything that we're doing in terms of returning data. Sometimes we want to compare it to what it was the previous week. And there are numerous approaches to that. For instance, you can create a rate calculator actually with a stored procedure. You don't have to use a function. And in fact, a function typically gives me more problems than anything else. So in some ways, a stored procedure is a preferred method because it's much easier to pass things through. But I'm going to go about doing a function just to demonstrate kind of an example of how to do a function and how it can be useful. Functions can be like math functions, but they can also be string functions. For instance, when I program in C#, I like to have a lot of my methods that involve like parsing strings. For instance, if someone tries to enter certain characters, it will spit it out and throw it away. And you can, in fact, these are very similar to what you would do in terms of methods in C#. As well, these functions are, in the sense that they're returning certain data. So just like creating a procedure, creating a function has some similarities. We have create function and then the function name, and then there's always the as, the begin, and then the end. And I like to just kind of type that out as the basic. You're going to get syntax errors of all kinds. Now the reason why I do MF rate is this stands for math function. For instance, there's also string functions. One of the functions that I've had would go through and, let's say, parse out all the commas. That's a string function, whereas this is going to be a math function because it's going to calculate a rate. Now keep in mind you can do it your own way, but I choose to do it this way here because it's the way that I organize things. But again, you could do UF, some people do it, the user function, some people do FN, some people do FUN, whatever you want to do. Now, I'm going to declare two variables here. These are variables that, just like with stored procedures, they get passed in. I'm going to declare a new and an old. And of course these have to take some value, so in this case I'm going to do decimals, and it's going to be 10 and 2, and the old is going to be the same as well. It's going to be a decimal of 10 and 2. So think about if we were calculating inflation rate. Inflation would be a certain value. Let's say the CPI is 3.2 one month, and the next month it's 3.5. So the new value is 3.5 and the old value is 3.2, and that's how we calculate an inflation rate. Now this function is going to return a value, and that value is going to be a decimal. And it's going to be a decimal 5, well actually I'll do 8, 4. That basically means that it is going to return returns, I'm sorry. It's going to return a decimal that goes to the fourth. It's going to return a number that goes to the fourth decimal place. So, for instance, the maximum. Wait, is that logical? I think it's 7.4. Yeah, the maximum really percent in this case is going to be 100% inflation or 300%. Just for this example, I'll use something short. But for instance, stock could technically go up 1,000,000%. It can only go down negative 100%. But it can go up to infinity. But in this case, I'm going to go to the fourth decimal place, or I can even make this easier and we'll just do the second decimal place. So this would basically calculate a maximum increase rate of 99.99%. Okay, and then we're going to return the value. Now this right here is going to be all math. So one second, I'm remembering how to do kind of math when I was a kid. So the way we calculate a rate is new minus old. So it's the new rate, or the new value I should say, minus the old value. And we're going to divide that value, whatever that is, by the old value. So for instance, if inflation last month was 3.5, that was, let's say, the CPI value. I should say it was 3.5, and the next month it's 4.2, you would say 4.2 minus 3.5, and then we would divide that by 3.5. We're going to divide that by the old value. And since this is a percent, all percents are multiplied times 100. That returns the percent. So we have created the function. Now and this is where functions are tricky, and this is the reason why I'm not a huge fan of them, because they're not always easy to call, and the syntax is not quite as straightforward, in my opinion, as stored procedures. So in our example that I used, I said the inflation rate one month was 4.2, and I'm sorry, 4.2, and the old inflation rate was 3.5. 3.5. Okay, so that's and of course, this is one of the things that if you just create a function, sometimes it's like, I don't know where that's at. Okay, so excuse me. So you can see 20%. So if our new inflation or our new CPI value for a month is 4.2 and our old CPI value was 3.5, that is an increase of 20%. So one of the keys here is, okay, so that's just a basic function, and functions can get very complicated. Like I said, I have string parsing functions. So what's the purpose of functions? This would be very useful to have, for instance, if you had, like for a rate as a case in point, if you had a table in which you had two values and you wanted to calculate the rate difference between those values. And so as a case in point, let's just suppose, this is just all hypothetical, but if you had a table where, I can't think of let's say a comparison between the US dollar and the Japanese yen, JPY. Okay, and you could calculate the rate between the Japanese dollar. Now, in this case, it's new minus old, so it kind of assumes it's the same type of value, like a CPI. But in this case, you're calculating the rate difference between two currencies. That doesn't actually make a lot of sense in some ways. No, okay, so it would be like the US dollar today and the US dollar, tomorrow. And you could have a table that had all this data in there, and then you could, instead of trying to go through and compare by doing like a self-join, and a self-join, keep in mind, you can do rates by doing a self-join. It's a very, very easy way to calculate rates, to calculate change, but this function will do it for you. You can apply it on a couple of columns and then go from there. And that's where functions can be useful. The most useful things that functions have done for me, at least, is string parsing. For instance, XML is a case in point. Is if you ever try to take XML and put it into columns of data, XML is incredibly disorganized, and especially if they don't follow a specific function, the people who create it, or a specific pattern, I mean, and a lot of times they don't. Having a function which addresses XML can be very useful, because I've used a lot of the SQL Server XML functions that they have, or not functions, but like nodes, and you select this and that. Those nodes work very well if the XML is organized very well. If it's very random, they don't work well at all. And so a function can really help you out. So like I said, these functions can get 300, 400 lines. But they're very useful when you have a stored procedure. You can call these functions on a couple of columns and return the data that you need without having to call another stored procedure, or without having to sit there and put that in that code. I mean, who wants to build 200 more lines of code in a stored procedure that could easily fit into a function? So this is a very useful thing, and when we're dealing with like administrative tasks, this can return rates of like how our database is growing. This can help us really figure out what type of administrative tasks are working well, or what type of administrative tasks may not be working well. But these outside functions can be very useful when we're working on our database and our tasks in our database.